So the thing about algorithms is that somebody will notice a pattern and they will think, how could we use that to do something? And what I'm going to demonstrate later is something called the merge sort. But this is where it came from. As you can see, the items in the list are in order, and if I move them apart, I've got a smaller list that's in order and another smaller list that's in order. I could do that again. I could break them down so that I've got a smaller list that's in order, a smaller list that's in order, and so on and so on. And I could even break it down so they were singles. So there's only one item in the list, which means it must be in order. But let me show you what this means. I'll demonstrate by breaking them down into twos. And what I'll do is, I'll mix them up. And then what I'm going to do is, I'm going to merge those two lists to make one big list. I'm going to merge these two lists to make one bigger list. And then I'm going to merge those two lists, and hopefully we'll end up with everything in this list back in the correct order. This is how we do it. Looking at these two lists, I'm going to take the first item from each one and I'm going to compare them. Smallest values go in there, I'm going to compare. Smallest values go in there. I have no more to take, so I just work through this list. There's my 3, there's my 4. I'm going to do the same with this. Take the first two items out of each list and compare them. Smallest item on this side, next item from this list, smallest item on this side. I have no more in this list, so I just copy my existing list over. I now have merged this list, and if you look, 1, 2, 3, 4 is in order, 5, 6, 7, 8 is in order. Even if I swap them round, because as long as I've got two sorted lists and I merge them correctly, they will still come out in the wrong order. So I'm trying to break it. I'm taking the first item from each list and I'm comparing them. There's the smallest item, I'm comparing. There's the smallest item. I'm carrying on doing the comparison, using the first item in this list and just moving along this one. There's the smallest item, there's the smallest item, and then all that remains for me to do is, because I have nothing to compare it with, I just copy this already sorted list across, and you will find that I get 1, 2, 3, 4, 5, 6, 7, 8. This is the basis for a merge sort, which I will now demonstrate. Okay, what I'm going to demonstrate is the merge sort algorithm. And what I've done is, I'm using an odd number of items in this list. That'll make it slightly harder to demonstrate, however it will show you that ordered lists of unequal sizes can still be merged. So, first thing I'm going to do is I'm going to break this one big list down into smaller ordered lists. And the easy ways to do that is just to treat them as, or treat this long list as 9 separate lists, each with one item. And because I only have one item in the list, then it must already be sorted and it must already be in the correct place. My next step is to start merging these single lists. So I'm going to take the first two. Now obviously I want the smallest value at this end, so that's the smallest. That list is now sorted. Same thing. That list is now sorted. That list is now sorted. This list, because it's the first item from this list and the first item from this list, is already sorted. That one goes there, that one I've got left. I've got one left. It's a list in its own right, so it's already sorted. So let's move these back and go through the process again. Only this time, each list, apart from the one on the end, has 2 items in it. I'm taking the first item from each list and I'm comparing them. And the smallest items go in there. I'm comparing. The smallest items go in there. That was from this list. I'm taking the next one and the smallest item is there. I have nothing else left. So I now have 4 items in this sorted list. Same here. First 2 items. Smallest goes there, and replace it with another item from that list. Smallest goes there. 3 and 6. And that list is also sorted. So, sorted list, sorted list, sorted list. I'm going to do the same again. Compare the 2 items. 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 I have nothing left in this list, so what remains from that one merely gets copied over. Now at this point, I have got a list containing 8 values and a list containing 1 value. And I want to merge them together. I simply look at the first item and compare it with the first item in the other list. It's 1. That's the smallest item. That's the smallest item. That's the smallest item. This is the smallest item. And because I have nothing else from this list to compare it with, I simply copy over the remaining values, and the result is a list that contains 9 items. 1, 2, 3, 4, 5, 6, 7, 8, 9 correctly sorted. That is the merge sort algorithm.